sound propagation in rooms. Up until now, we've considered how sound propagates outdoors and the different parameters that affect what is heard at the listener location. When we consider sound entering rooms, the sound level at any point inside the building will usually be a combination of the following: sound arriving directly from a sound source that's located within the building itself, sound transmitted through building elements from the outside or adjacent rooms, sound transmitted through ventilation openings such as air gaps and open windows, and then sound reflected off the inner surfaces of the space. Firstly, let's look at direct sound. If you think of someone speaking at a lectern in an auditorium, the direct sound is that comes directly from the speaker's mouth to the listener location. What then also happens is, as well as sound arriving directly at the listener location, there are early reflections of sound off the closest surface finishes in that auditorium. These early reflections can be useful to actually augment the direct sound quality. And for speech clarity, any sound arriving within 50 milliseconds of the direct sound can be considered as useful early reflections of sound which improve the sound quality of the spoken voice. After early reflections of sound are heard by the listener, there are late reflections of sound. Late reflections are considered to be detrimental and result in reverberance in the space. For speech purposes, any sound arriving later than 50 milliseconds is considered to be late arriving and impair the speech intelligibility in the space. Let's have a listen to the difference between direct and reverberant sound. So remember, direct sound. Sound travels in a straight line between the source and the receiver. The direction's easily discernible depending on the level and the number of sources. It's independent of the room characteristics. And of course, it's affected by directivity. We've talked about directivity and the directivity index in previous sections. So let's have a listen to direct sound. Let's place that same sound source within a room that has hard reflective surface finishes. So the attributes of this space include that the sound field is built up in the room after multiple reflections of sound. For reverberant sound, it is the same sound pressure level at every location in the room. We have a reverberant sound field. The direction is indiscernible. Because sound is reflected off the inner surfaces of the space, it is hard to determine the direction of where that sound's coming from. And the amount of reverberation in the space is highly dependent on the room characteristics, whether there are soft finishes in there or hard and reflective acoustic finishes. So have a listen to this same sound source in a hard reflective space.